Hey everyone, and welcome to The Explainer. Today, we're talking about something huge happening in AI, a total shift in how we think about getting work done. We're moving away from this dream of one single, all knowing AI and towards something way more powerful: AI teams. It's a real game changer for automation, so let's dive right in. So let's just start with the big question, right? Can one AI really do it all? I mean, we're building these incredibly powerful models. It seems like we should be able to just toss any complex problem at it and say, go figure it out. But, well, the answer might not be what you think. The answer is no. A single AI can't do everything. And get this, that's actually its secret weapon. The fact that it has limits is precisely what unlocks the next level of what's possible. It sounds completely backward, I know, but it all comes down to something called the lone genius problem. Okay, so think about it like this. Imagine you're in a meeting trying to discuss quarterly sales numbers, a software bug, and what everyone wants for lunch all at the same time. Your brain would just short circuit, right? Well, it's the same for an AI. It's a problem we call context bloat. When you cram too many different tasks, tools, and transcripts into its short-term memory, its context window, it gets totally bogged down. It becomes slow, way less effective, and, because every bit of that information costs money to process, it gets incredibly expensive fast. So if the lone genius approach is a dead end, what's the solution? You build a team. But for an AI team to actually, work together, they need a way to communicate and a way to use their tools. And that's where two new protocols come into play. They're basically the connectors that make the team function: agent to agent, or A2A, and the Model Context Protocol, or MCP. Let's break down what those actually do. First up, you've got A2A. The easiest way to think about this, it's like a secure private social network, but for AIs. It's a protocol that lets different, specialized agents, even ones built by totally separate companies, find each other, understand what they're good at, and then team up on a task, all without some central mothership controlling everything. Okay, so with A to A, the agents can talk to each other. But talking isn't enough, right? They need to be able to do things. They need a standard way to plug into all the different tools they might need. And there's this fantastic analogy from AI engineer Damian Murphy that just nails it. He calls this standard the USB-C for AI. And that's exactly what the Model Context Protocol, MCP, is. It's that universal plug. You know how with a USB-C port you can connect your phone, your monitor, your keyboard, basically anything? MCP aims to be that for AI. It provides a standard interface so any agent can connect to and use thousands of different external tools. We're talking sending a Slack message, creating a GitHub issue, or pulling data through services like Zapier. It's the action part of the puzzle. So let's just put it all together to make it super clear. A to A is for agent collaboration. It's the team's communication system, how they all talk to each other. MCP is for tool connection. That's the team's equipment, how any single agent can pick up a tool and use it. One connects agents to agents, the other connects an agent to its tools. You really need both for the whole system to fly. Now, this sounds incredibly powerful, and it is. But you don't always need to assemble an AI super team for every little thing. Knowing when to use these protocols, and maybe more importantly, when not to, is absolutely key to building things efficiently. So here's the rule of thumb. You call on the team when you're dealing with the outside world. If your AI needs to connect to a third-party tool that you don't control, or if you want to use a specialized agent built by another company, like, say, a dedicated Salesforce agent, then A2A and MCP are your answer. They're for building complex workflows that have to reach outside of your own systems. And the flip side? This quote makes the point perfectly. If you control all the agents and all the tools, if everything is internal to your own system, then using these protocols is just unnecessary overhead. As Damian Murphy puts it, why plug in an external hard drive when you can just use the one that's already in your machine? You just have your functions call each other directly in the code. Way simpler. Okay, theory is one thing, but let's actually see how this plays out. We're going to walk through a real-world example of a business process that's completely automated by an AI team. It's pretty cool. So here's the scenario. A sales call on Zoom or Teams just ended. The very moment it's over, An automated trigger, it's a little thing called a webhook, grabs the entire transcript of that conversation and sends it over to our main coordinating AI. We'll call this one the host agent. And this is where the teamwork really shines. First, the host agent skims the transcript and identifies two key action items. The customer reported a bug, and they also suggested a new feature. Second, delegation. The host agent is a good manager. It doesn't try to do everything itself. It hands off the tasks. So for step 3, it tells a specialized GitHub subagent to create a new bug ticket. At the same time, for step 4, it tells a Slack subagent to post that feature idea into the product team's channel. And finally, step 5, the subagents just ping back with a simple success message, and the host agent marks the whole job as done. It's clean, it's parallel, and it's incredibly efficient. Now, this whole process is awesome because it's fast, but that's not even the best part. The real secret sauce, the single biggest advantage of this entire team-based approach, is all about managing that AI's short-term memory, that really important context window. Just look at the difference. The single genius agent has to hold the entire transcript in its memory, plus all the instructions for how to use GitHub, plus all the instructions for how to use Slack. Its memory is totally bloated. The result, it's slow, expensive, and hits its limits really quickly. But with the AI team, what does our host agent have to remember at the end of the day? Just 2 simple things: bug filed and Slack message sent. It stays fast, cheap, and scalable. And this chart just makes it crystal clear. That monolithic agent on the left, its memory is 95% full. It's completely maxed out and can't take on another task. But our host agent on the right, it barely broke a sweat. It used maybe 10% of its capacity. It's lean, it's fast, and it's ready for whatever's next. And this isn't just about performance. It's about cold, hard cash. That bloated context from the single agent, if you want to keep it around to ask follow-up questions, caching it can cost 3 times more than the initial request itself. That's crazy. By keeping the context lean with this team architecture, you are directly saving a significant amount of money and making the whole system better. So let's zoom out. What does this all mean for the future of automation? It points to a really clear, really powerful new direction. The big takeaway is this: the era of the lone, do-it-all genius AI is basically over. The future isn't about building one single, perfect AI. It's about creating these dynamic, flexible ecosystems where specialized AI agents can collaborate, delegate, and work together. Honestly, just like a high-performing human team. And that leaves us with one final, pretty provocative thought. As these AI teams get more and more sophisticated, connecting across companies and automating these incredibly complex workflows, it forces us to ask a whole new kind of question. What work can't be automated? What's really left? It's something to think about.